and foreland basin deposits. Professor Shukla is serving as a professor since 2008 in the Department of Geology, Banaras Hindu University. His main research interests lie in sedimentary geology, fluvial sedimentology, quaternary geology, paleoclimate reconstruction, sequence stratigraphy, sedimentary processes and phases analysis, petrography, and study of trace fossil and geoarchaeology as well. So now, with the permission of the chair, I would like to request Professor Umakant Shukla to present the talk on the incision of the Ganga river near Varanasi, a tectonic response. Welcome, sir.
Thank you, San. Thank you for the good words, and good afternoon to everybody. As San told, basically I am a sedimentologist, and based on sedimentology, whatever tectonic features are available, I try to use them to create my own story. So doing the same, I carried out some work around Varanasi because I am located in Varanasi, and it is a very interesting area as far as the geology, geomorphology, and Lord Shankar is concerned. Varanasi is known both for Baba Vishwanath and Ganga Mata. So it was interesting to me, so I started working on this area and tried to do something. So the topic of my presentation today is the incision of Ganga river near Varanasi, a tectonic response. This is a three-dimensional cartoon which shows the geotectonic setting of the Indo-Gangetic foreland basin. In the north, we have the lofty, tectonically active Himalayan range, then broad, wide alluvial plains drained by many rivers, and in the south we have another dynamic regime, that is the peripheral bulge. So this shows all the components of a foreland basin. All along the Indo-Gangetic foreland basin, if we look at this, we will find that it shows some geomorphic elements which are of regional significance and of genetic importance. For example, in this figure, you can see some lobate bodies in the north. They are the mega fans and the Piedmont fans. Then we have the T2 surface, alluvial surface, and in the south we have again a type of alluvium which is little bit different from what we get in the north in the form of the alluvium, and then in the south it is a peripheral bulge. This from east to west also and from north to south, the Indo-Gangetic foreland basin can be divided into four. The westernmost part is known as or named as Punjab Rajasthan plain. Then number 2, Ganga plain or Ganga basin. Number 3, Bengal plain, and number 4, Brahmaputra plain. Our focus of study for the last more than 2 decades has been the Ganga plain, which is the central sector and the largest sector and occupied by the largest river, the mighty Ganga. The lower one is the drainage map of the Ganga basin, where there are a number of major and minor rivers. The major rivers like Ganga, Yamuna, Gagra, Gandak, Kosi, etc., they all originate in the glaciated terrain of Himalaya, and they carry huge amount of sediment, particularly during the rainy season. Now, if we look at the geomorphic element, then at least 3 geomorphic elements are very much visible, very much obvious. In the Ganga plain, in the north at the foot of the Himalaya, running all along the length of the Himalaya, there is a gravelly surface which is known as the Piedmont surface, Piedmont fan surface. It is 10 to 50 kilometer wide, and it is made up of gravels and a little sand. Then we have a very wide alluvial plain, about 100 to 200, more than 200 kilometer wide alluvial plain, and then we have the marginal plain and the peninsular craton, which is acting as the peripheral bulge. The important thing which has to be noticed is that in the present scenario, the Ganga, which is the axial river. Well, this is also the trunk river because before Allahabad, Yamuna acts as the axial river because it occupies the lowest position of the four-land basin. But when Yamuna meets to Ganga at Allahabad, then the Ganga starts acting as the axial river. So all the time Ganga is either the trunk river or it is the axial river. But the scenario and the most important scenario, the most important thing which has to be noticed is that this plain is receiving a bimodal sediment. The huge sediment coming from the Himalaya, being brought by the rivers which are draining from north to south, like Ganga, and other rivers which are meeting the Ganga from the north. And there are the rivers which are originating from the peninsular India, and they are flowing towards the north or northeast, either meeting to the Yamuna or then meeting to the Ganga. So the Ganga plain has the sediment supply from both north and the south. Obviously, the most of the sediment comes from the north because in the north we have the Himalayas, and they shed a lot of sediment, and the sediment is carried, particularly during the rainy season, huge sediment is carried. And some of the sediment is also going to the Bay of Bengal, where we have the delta, and therefore the history of the Indo-Gangetic plain as well as the Himalayas is also coded within the delta also. So this plain provides an archive to study the influence of tectonics, climate, and of course the sea level changes. These are known as the allogenic factors to which these river systems are very sensitive. So we have tried to evaluate the relative role of this allogenic forcing on the rivers of the Ganga plain. This map shows a detailed geomorphological features of the Ganga plain, where we have at least six surfaces of regional significance and genetic significance. Like we have the lobate bodies starting from the mountain foot, like the mega fans, Ganga Yamuna mega fan, Sharda fan, Ghagra fan, Kosi fan, and then the smaller fans, gravelly fans, Piedmont fans in the north. And again, another important thing which I would like to emphasize is that the major rivers like Ganga, Yamuna, Gandak, and Ghagra, which are draining from north to southeast, cutting across the Piedmont zone and the megafans and the T2 surface. The T2 surface is the oldest geomorphic element of the Ganga plain. It is a flat-lying surface, and all other geomorphic surfaces are overlapping on this surface. So all these rivers, they are cutting across all these surfaces all along its length, right from the mountain foot to the Ganges Delta. But the level of incision is different. Certainly in the north near the mountain foot, we have the higher incision level. Then in the central Ganga plain, the incision of level decreases. And again towards the marginal plain near the peripheral bulge, we have the increased incision of these rivers. So almost all rivers, smaller or the larger rivers, they have the cliffs of different heights along their channels present either on one side, mostly they have on the southern side, but at different places they have the cliffs on on both the sides of their channel. So it is obvious that the smaller or the larger, whether the snow-fed larger rivers or the alluvium-fed smaller rivers, they all are flowing incised, but the level of incision varies. Now again, a point of discussion, a point of investigation, and the hottest spot for the research is that what is the cause of the incision of these rivers? Is it an autocyclic process by which rivers erode and incise, or it is some allogenic control which is forcing the rivers to incise. This is the point of discussion. And here comes the relative role of tectonics, climate, and the sea level. Many people argue that Ganga plain is far away from the Bay of Bengal. How the sea level can affect the river in season. But the Ganga plain has the archive and the history of whole right from the Pleistocene to the Holocene and the present day. And many things happened during this time period. We had the LGM at 20 kilo years ago, and at that time the sea level was at least 100 meters below from where it is today. So the sea level, if it is standing 100 meters below, then certainly it is going to have some effect on the river channels which are meeting to the coast. And if it is so, certainly the river systems are going to be affected by the higher low stands. There may be a time lag. There may be a time lag that they are responding more quickly at near the coast and less and slowly and less away from the coastline, but they should have the effect of the sea level. This is our theory. Many people are negating it. So if we see the imagery also, we see these fans which are very handsome at the mountain foot. They appear very handsome, like this is a Piedmont Gola fan. The mega fans being larger, they are generally not visible on the imageries, and we have to draw a line where they intersect the channel of the T2 surface because they are overlapping on the T2 surface. But this imagery is just to show it that our mapping, it is ratified everywhere. Now in the central alluvial plains, the scenario is like this. You can see a light tone T2 surface, you can see a dark tone T1 surface, and also there is a T0 surface. T0 surface is the present day active channels and the associated floodplains. T1 surface is known as the river valley terrace, and it is believed that at the time of the high discharge, the rivers which are today flowing at the T0 surface but flowing at T1 surface, and they created the river valley terraces. Sedimentologically, if we compare the grain size of the T0 or the grain size which is being carried by the modern rivers, it is smaller than the grain size what is constituting the T1 surface or the river valley terrace. So it is very logical to conclude that at the time when the T1 surface was formed, these rivers were more energetic and they were bringing the larger grain size. Both these surfaces, they are in size. See the dark line on either side. Both these surfaces, they are in size within the T2 surface, which is supposed to be the largest, oldest geomorphic element in the Indo-Gangetic plain. Again, the important point which I would like to emphasize is that this T2 surface shows a sedimentological succession comprising sand, silt, and little mud, which is unrelated to the sediment being brought by the present day modern channels. And that is why this surface was named as the interfluve surface or the Doab surface. So the dynamics of the T2 surface is different from the dynamics of the present day rivers flowing at T0 surface, that is 10 to 20 meters below or cutting into the T2 surface. There is also an elevational difference between the T0 surface and T1 surface of 4 to 5 meters, at certain places 8 meters. So there were different episodes of incision. There was a time when the rivers incised into the T2 surface, and then it formed the T1 surface, and later on or subsequently it cut into the T1 surface to gain its present thalwich, on which the rivers are flowing. This is the scale 20 kilometer. Now if you see with respect to this scale, you will find that at different places the Ganga river has a very wide valley ranging from 20 to 10 to 20 kilometers. When we will come to Varanasi during this talk, we will find that how narrow is the valley at Varanasi. This slide shows the different types of abandoned channels and the huge meanders which are present on the T1 surface, where at one time these rivers were flowing. So they created different types of geomorphic features on the T1 surface, and later on they got incised, and every time there had been a reason for incision, either tectonics or climate or the sea level, we have to explore. This is another important slide near Allahabad, where a continuous abandoned channel belt is present north of the present river Ganga. Now you compare the morphometric parameter qualitatively. Looking at this slide, you will find that this abandoned meanders of the abandoned channel belt, channel width, and the valley is very much comparable to present day Ganga. Recently, the NGRI group published a paper in Science, and it is the idea which is propagated is that this abandoned channel can be the old Saraswati. Methodologically, we believe that Allahabad, there is a junction of three rivers. We also have the Saraswati. But to me, working on the Gangetic plain, I believe that I don't negate the view, but I propagate the idea that this abandoned channel belt, which is parallel to the present day Ganga, may be the initial location of the Ganga when the Ganga was meandering. And then, because of again the allogenic forcing, the Ganga shifted to south and attained a braided character. It happened not only with Ganga. If you look at Yamuna, we have published. If you look at Yamuna also shifted from north to south. So it is a general tendency of the rivers of the Ganga plain to show the features that they have shifted from north to south in general. So this block diagram shows the present day scenario of the rivers in the central Ganga plain, in the alluvial plain. You have the T0 surface, the rivers and the associated floodplains which are vegetated, they are narrow. This is incised into T1 surface. The elevational difference is 5 meters, 6 meters or 8 meters sometimes. And this surface is actively contributing the sediment to the present day river. Again, important point. This surface, T1 surface, has its own network of channels. It has the meander scars I have shown you in the imageries, and both these surfaces, they are incised into the T2 surface, which is unrelated to the present day surface. This paper we published in Facies long back in 1999, and at that time we were working with our Guruji, late Professor I.B. Singh. Myself was there, Pradeep was there, who is sitting in the audience. We had the Hussain Singh and many others which were associated in the team. We did the extensive field work, and based on that, this model was created. And this model shows that the T2 surface is altogether a different overbank domain, which is unrelated to the fluvial channels, current day fluvial channels. And this is certainly an addition to fluvial sedimentology. This has already gathered more than 70 citations. Now, I will come to Varanasi, which is the focus of my study. And this is the slide which shows the northwardly flowing Ganga river. This is at the flood time when the Ganga appears meandering. But if you see this Ganga during the lean period, during the summers, you will find that the mid-channel bars, they emerge, and it starts looking and showing all the characters of a braided river. So should we call it a meandering river, or should we call it as a braided river? It is again a question. But sedimentologically and geomorphologically, I looked the river during the flood time, and it shows a meandering character at Varanasi. But if now you see and contrast between the river valley width, the slide I have shown, it was near Kannauj, 20 kilometers, and here this is the river valley. On the right hand side we have the Ramnagar area, on the left hand side we have the Varanasi area, and the width of the valley is 1 to 1.2 kilometers only, very narrow. This slide again, you can notice that this is the Varanasi. From Chunar to Saidpur, this Ganga river shows anomalous character of meanders. See, these meanders are distorted. Some meanders are smaller, some are larger, some are box shaped, some are conical. So from Chunar to Saidpur, the stretch where Ganga is flowing towards the northeast against the slope, because the general slope of the Ganga river, the Ganga plain, is towards the southeast. और बनारस में कहते भी हैं कि नॉर्थ वाहिनी गंगा, उत्तर वाहिनी गंगा, और इसको पूजते हैं हम कि यहाँ पर भगवान शंकर की वजह से गंगा नॉर्थ की तरफ बह रही है. So this is a very important feature which Ganga shows at Varanasi. It flows towards the northeast and it shows distorted meanders. There are certain rivers which are coming, tributaries coming from north and meeting to the Ganga, for example, Gomti meeting at Saidpur and the Varuna meeting at Rajghat. Likewise, there are many rivers like the Jhargo rivers which are originating from south, flowing towards the north and meeting Ganga on the southern bank. Now again, a point to emphasize that here, no river coming from south can cross the Ganga river and deposit the sediment on the Varanasi river, on the Varanasi side. Likewise, no river coming from the north joining the northern bank of the Ganga can deposit its sediment on the southern side. Please remember this point because this has the implication further in my talk. Like I told that all the rivers are incised. At Varanasi also we have the incision of Ganga river, and this is on the left hand side. This is the cliff section which is about 15 meters high. Ganga is incised by 15 meters, and on this cliff is located the Ramnagar area. On the right hand side, which is not visible, is the Varanasi, and towards the Varanasi also it is a very gradational rise. Our campus of BHU is located much higher above the Ganga. It was the vision of our Madan Mohan Malviya ji to locate the campus where it is today, and they realized that water of floods, even the catastrophic flood, will not inundate the campus. And it is true. It was during the 1984 only when some water reaches to the BHU gate, otherwise the campus is never inundated. So it is also located on the region surface, T2 surface. We studied this cliff section by making the trench from bottom to top. Sedimentologically, this whole cliff section was documented. We collaborated with the archaeological people, which studied the cultural layer lying at the top. We had the OSL dating, and I would like to tell you here that the dates were OSL dates were produced by Dr. Pradeep Srivastava, who is sitting and listening this talk when he was in Wadia Institute of Himalayan Geology. The dates were based on protocols using quartz as well as the feldspars. These dates also rectified a question which was raised very vigorously long back, that these dates based on quartz, they are wrong. So we here used both quartz and the feldspars, and our dates were matching, and that was of course hurriedly published in the Himalayan Geology. But these dates, they helped us to create a history of this particular place at Varanasi. The sedimentary package 1 is dated between 60 to 40 years. Then, and this surface shows the arcosic sediment derived from the south. Important again. Above this sedimentary package shows all the characters and the sediment derived from the north, and above the layer which was dated 7K, above that we have the cultural artifacts. So here in this cliff we have the sediments derived from south and the overlain by sediments derived from north, that is the Himalaya. Now I have emphasized that in the present scenario, no river coming from north can cross the Ganga and deposit the sediment, Himalayan sediment, in the south. Likewise, no river coming from south can cross the Ganga and can deposit the sediment in the north. But here at Ramnagar, we have the Creton-derived sediment at Ramnagar, which lies in the north, overlain by the sediment derived from the north. There is a very marked surface between the sedimentary package A and the sedimentary package B in the form of a calicritized layer. I will show you the close-ups of these slides, and that indicates that there was some gap also between the sedimentation of the lower package and the upper package. But one thing is clear, that at about or up till 40 kilo years, the rivers coming from south, draining from south to the north, were coming up to the Ramnagar. Means at that time Ganga was not here where it is flowing today. Otherwise it would have not happened. Important. And then it has the package, overlying Himalayan package, that also indicates that when the Ganga came near to the Varanasi at about 40,000 years ago, there were the interaction of rivers coming from north and south. And after some times, when the time passed, even the humans occupied the top surface and left the archaeological evidence at the top. At the top we have the lead. I mapped the whole of the cliff section right from the Ramnagar fort, just in front of Varanasi, to the bridge, the Calcutta highway. The total distance is about 1 kilometer, and notice the interesting structural features which are excellently preserved in this cliff section. We have a thrust plane affecting the package A as well as the package B. We have the anticlines, we have the synclines, and the top surface is undulatory, which is occupied by the men in the geological past. I will tell you the significance later. These are the close-ups. You see the pink sediment or posic sediment derived from south, and there are the rhizocretes on the top surface of this layer, which indicates that this surface was exposed for a certain time period, and if the vegetation grew on this surface, the evidences are left in the form of the rhizocretes or the root traces. The top surface of this package A is a calcritized mud layer, which is feebly pedogenized layer, but certainly not a mature soil that takes to form many thousands of years, 10,000 or 12,000 years. So there may be a little gap of a few thousand years between the package A and the package B. Again, this is the other facies, cross-bedded facies, but the liquefied sand is very important. You can see that the whole surface or the whole bed thickness is highly liquefied, deformed, since sedimentary deformation is present. This type of deformation takes place in the sediments when there is an earthquake shaking. So this is a very strong evidence in our hand that shows that maybe at about 40K, when the Ganga was brought near to the Varanasi, there was an intense tectonic turmoil, not only at Varanasi, but also in the entire Gangetic plain, because this liquefied surface dated as 40K is well correlatable to a liquefied surface dated at Kalpi. At Kalpi, which is about 350 kilometers away from Varanasi, there also a surface dated as 40K is complete sand surface is completely liquefied. So it led us to conclude that most probably this 40K event was very intense. These are the lithofacies, cross-bedded sand, gray sand, mud, and the mud with the shells indicating the existence of the lakes and the ponds, and the overbank mud, mottled mud. And you can contrast even by the color that the sediment package, which is arcosic, is entirely different from the overlying Himalayan package, which is grevake sand. The perceptible difference is that this Himalayan package sand, which is in the local dialect, is also known as balu, जिससे हम plaster करते हैं, and the Creton-derived pink sand is known as morang, जिससे हम छत ढालते हैं. So both are different. They are mineralogically by look, and this Himalayan package is rich in mica, whereas the sediment coming from south, it is devoid or poor of mica. And this is the picture of the topmost cultural layer, where you can see the soak pit, a pitcher, a ring bell, and my team or my collaborators, retired Professor Vidula Jaiswal, who was Professor of Archaeology, is Banaras Hindu University. She dated that it belongs to Kushan or the Gupta period. So we can appreciate the technology available at that time, that how nicely they have created a soak pit and the pitcher. I call it as a bathroom complex. Now, this observation that we have a Creton-derived sediment at Ramnagar cliff, in the Ramnagar cliff, is also rectified by the borehole data which is available on the Varanasi side. We have a deep well of Central Groundwater Board at Chowk, Gurubagh, DLW, and you can see that the Himalayan derived and the Creton derived sand, and at least in different boreholes, the Creton derived sand is lying below 50 to 100 meters, 50 to 100 meters below, 50 to 70 meters below from the surface on the Varanasi side. Now see that on one hand, the Creton derived sand is exposed on the surface in a cliff which is just 10 to 15 meters high. And on the other hand, on the Varanasi side, the same sediment is lying below 50 to 70 meters. What does it indicate? It indicates a fault. It indicates the activity of the fault, where the Ramnagar side is the upthrown side and the Varanasi side is the downthrown side. I will elaborate this point again in my talk. Now, this is black and white picture of the tracing of the cliff, and here below, see the B, you can see that there is a thrust which is affecting the package the 1 and also the package Himalayan package B, that these are the units 1, 2, 3, 4. The Himalayan package can be identified into 4 packages, 1, 2, 3, 4, and this fault has at least affected the package 1 and also created the a throw of about 2 to 3 meters, because in the hanging wall of this thrust, or I will call it reverse fault, not going into the controversy what is thrust, what is fault, I call it as a reverse fault. But the lower stories of the package 1 are also visible on the hanging wall. So if I measure it, the throw is 2 to 3 meters. And this event also most probably affected the whole cliff section, which created folded and faulted the whole package. And this event, because I would like to, well, I left it that I would like to emphasize one thing more, that this is the layer. This is the sediment horizon and the layer, which is dated 7K, OSL dated 7K, that the top of the Himalayan package is dated 7 kilo years. And this surface, though this slide is because of the missing grain contrast, this is not very much clear as it was in the package 1, but this surface is also liquefied. I have some better slides, but I think I don't know whether it is clear to you or not, but this surface also shows liquefaction. So we say that the second tectonic event which affected whole of the cliff, which created the reverse fault, which created the fold, which created the anticlinal and disinclinal structure, it took place at 7K. So there were at least 2 tectonic events which took place in this area. 40K, where the Ganga came near to Varanasi, and the 7K, when the Ganga came at its present location and got incised. Now again, Ganga incised at 7K, this is our result. Now again, what may be the region of incision? We have structures like the reverse fault, we have the folding, we have the faulting. So based on this and on another evidence that we have the orthozic sand present at the surface, and on the Varanasi side it is lying below 50 meters. These evidences indicate that no, there is a promising role or the commanding role of tectonics in the Ganga river incision. This 7 kilo years event brought Ganga to its present location where it is flowing, and the incision took place at 7K. This is the second conclusion. Now see the field photographs of this thrust plane. This is the horizontal package A, this is the fault line, and this is inclined hanging wall, where we have again the pink lower beds of the Pink River, and at the top we have the Himalayan sediment. See the dips of the beds. The river is flowing on the right hand side, just along the river. You see the tectonic tilt. You see the tectonic tilt of the beds. Here in the third photograph, the steep dips. We also have the vertical cracks filled with the calcite, another evidence of tectonics, neotectonics rather, cracks which are filled with the calcite, and they are affecting the whole of the sedimentary package A. Now I will again use some imageries that we have different evidences which are giving you, pointing out, emphasizing, and the third evidence which indicates that this area is tectonically active, and most probably there is a fault because of which Ganga is flowing towards the northeast against the slope. For that, there is another evidence. I started looking at the junction point of the tributaries of Ganga meeting on the northern bank as well as on the southern bank. This is the valley of the Gomti Nagar, old Gomti river. This is a river, Jhirgo in south. I will show you individual slides for that. And the Varuna river, which is present in Varanasi. All these rivers which are coming from the north and meeting the Ganga as tributary on the northern bank, they have shown the shifting from north to south. I will show you the individual slides. In discrete steps, they shifted their contacts from north to south. In contrast, the rivers coming from south and meeting the Ganga on the southern bank, they shifted the confluence points from south to north. It is very interesting that on the northern side, rivers are changing the confluence point and shifting the channels from north to south, and on the southern flank, the rivers are shifting the confluences from south to north. Why? Why? Again, question why? What is causing it? See, the Gomti River is stage 1. This is the present confluence of the Gomti River at Saidpur. And you see the paleo channel, trace it, you will find that it was meeting further north, in the north at one time, that is the stage 1. Then it came to the stage 2, and the present day confluence is stage 3. See, first, second, and Saidpur. At Saidpur now the river is meeting here, and it had shifted in discrete steps thrice. Now, I don't know why it shifted from stage 1 to stage 2. The aerial distance is much, but from stage 2nd to stage 3rd, that is the present location, we carried out the field work and we encountered a very huge lake at Kathi. At Kathi, there is an abandoned oxbow lake. We talked to the local people, and they told us that the river changed its course during the flood of 1978, so as to occupy the shorter route. The Ganga, the Gomti relieved its meander, which is present today in the form of an oxbow lake. This shifting is certainly climatic, because it happened in 1978 when there was a catastrophic flood. So it is not that only that tectonics is doing everything. There is a combined role of climate and tectonics. The point is still we do not have any tool to discriminate that this is the because of climate, this is because of tectonics. The role is always relative, because both the phenomena, they occur together. Well, the tectonics is a long-term process, climate is a short-term process, but sometimes they either negate each other or support each other to bring out such changes in the river systems, because river systems are equally sensitive to the climate, and they are also forced by the tectonics. Now this is the Varanasi site. This is, you see, the width of the Paleo Valley. I have traced a meander. This is the present day river, and Varanasi side is the cut side, whereas the Ramnagar side, opposite side, is present a huge point bar, which is the depositional site. Now when I go to class and teach my students, I ask the question, why the ghats of Banaras were constructed on the convex side of the river Ganga? Our ghats, why? It had some reason, and it has some reason. Because if you see the meander, active meander of the Ganga river, it is present towards the Varanasi side. Had not been there the ghats, by now the Ganga might have eaten the Banaras. Our ghats protect us from the energy of this river. But at one time, the river was flowing at a point 1. We have the meander scar, the high toned surface over which the Banaras is located. And there are a number of dark bodies now in the Banaras which are known as Kund. They are named, given different names, Kund, and they are supposed to be very pious. But to me, as a sedimentologist and a man working on the river, I explain the presence of the ponds by explaining the disintegration of channels and the shifting of channels. Well, at one time, the river was flowing at 1. And then it shifted to 2, to the Ramnagar site. And then at 7K is claimed present at location 3rd. And this happened This third position where the Ganga today is flowing, according to us, it took place 7 kilo years ago, and the Ganga got incised. Now Ganga is confined to its incised valley and cannot leave its place at Varanasi. It has a very narrow valley as compared to what is the valley width further in the south and further in the north. And see, this was the valley width at that time, within which the Ganga was oscillating from 1 to 2 and 1 to 3. This is the scale 5 kilometer, and this is the paleo valley of the Ganga, which is about 10 kilometers. So at one time, when the Ganga was vigorously moving east, west, north to south, and shifting laterally, because it is trend is northeast in this, so we have to talk in terms of east and west also. So it was oscillating within its valley, and finally it came to position third, where it got incised. And this has the implication to the archaeology, that the archaeology has dated the artifacts at Ramnagar, that the Ramnagar came into existence at about 3000 years ago. And if the Ganga came to its present location where it is flowing, Ramnagar located on the bank of it, then what happened to rest of the 4000 years when the Ganga came to Varanasi, got incised, Ramnagar cliff was raised at 7 kilo years ago, but the culture started only 3000 years ago. And the culture of Ramnagar is contemporaneous to the Varanasi, dated on the artifacts at Rajghat, very important place in Varanasi, Rajghat. So both the localities, they were contemporaneous, but with time, the culture of Ramnagar faded, but the Varanasi, the culture of Varanasi, the growth of Varanasi, the oldest living city, it was never took a break. It was continuously growing, and that's why we call the oldest living city of Varanasi. And this is the confluence point of the Varuna River. This is the present confluence point of the Varuna River. This is the abandoned channel of the Varuna River at Rajapur. So Varuna also shifted from north to south. This is the Jirgo River, coming from south and meeting to the north. You see, at one time it was meeting here, and now it is meeting here. It shifted from south to north. So the evidence is in hand. They indicate that at Varanasi, between Chunar to Saidpur at least, Ganga is flowing along a fault. And the evidences of confluence shifting, they indicate that it was a right-handed strike slip fault. And since we have the sediment or cosic sediment at the surface or at the Ramnagar and 50 meters below on the Varanasi side, we say that this was a right-handed strike slip fault with a gravity component. A strike slip fault with a gravity component, a type of wrenching, I think. I don't know, the many structural geologists sitting here, they understand much better than me. So this is a trend of a fault at Varanasi, northeast, southwest. It is not only in Varanasi, a fault has already been diagnosed at the junction point of the Yamuna and the Ganga rivers at Allahabad by Pati of Allahabad University. So again, I put this to refresh you that there is an important event at 40K and there is important event at 7K, and then we have the cultural layer, the oldest artifacts dated as 3000 years. So what happened for the 4000 years? It was displayed well what happened by the archaeological pits. Professor Vidula Jaiswal ji dug 3 pits 5 to 10 meters in depth on the Ramnagar cliff, and they found the oldest artifacts at different levels in these 3 pits. In one pit, the oldest artifacts was present below the surface, only 3 meters below the surface, while in another pit, the oldest was encountered at 8 meters below the surface. What does it indicate? That it indicates that when Ganga came finally to this place at 7K, the Ramnagar cliff was raised because of the tectonic activity. For 4,000 years, the surface of the cliff was degraded, and it attained by the ravine development most probably, and it attained a differential topography. But now the river was confined to a narrow valley, and people at that time might have noted that now there is no danger of flood. They came and colonized the surface of the Varanasi. So they have colonized at different levels at the same time, because that surface was degraded, and there was the low-lying area, there were the high-lying areas, so the whole surface was occupied. So we have the artifacts of the same age at different level. That indicates the degradation of the surface after its upheaval. It is also important to mention here that just about 150 kilometers away from Varanasi in Pratapgarh, we have the Paleolithic sites, Paleolithic to Mesolithic sites, documented by Archaeological Survey of India. But in Varanasi, we do not have anything older than 3,000 years. Why? It is because the Ganges was very vigorously moving within its valley from the point 1 to point 2 to point 3, rendering the area, most probably rendering the area unsuitable for habitation. People colonized, settlements started only when people noticed that now this area is safe, river water does not reach to Ramnagar cliff or the Varanasi site. So this is a model which indicates the shifting of the river Ganges. This is before 40K. This line shows the Ramnagar section or the Ramnagar cliff. Ganges was flowing away. At about 40 to 7, it oscillated from one place to another place. It went to Ramnagar side, created a cliff, and that at 7K it came to its present location, and because of the fault tectonic activity, it got incised. So I have some conclusions in hand to share, that at Varanasi, Ganga flows along a strike fault with a gravity component. Ramnagar cliff section represents Khadar, or the river alluvium, that is the river valley terrace. The surface is the result of the interaction of rivers flowing both from north and south. Area witnessed 2 tectonic events. First around 40 kbp, followed by the second event at 7 kbp. River Ganga came near to Varanasi about 40,000 years BP, and to its present location at 7,000 years BP. The main reason of Ganga river incision is tectonic. The main reason of Ganga river is tectonic. This is the conclusion. Well, I don't negate the relative role of climate, because at that time the climate was also more humid as compared to present day climate. But there is a more obvious role of tectonics which might have led to the incision of the Ganga river. After the uplift of Ramnagar area, about 7K, the surface was degraded for at least 4,000 years before it was occupied by the man about 3,000 years back. Thank you very much. Thank you for patiently listening.
Thank you, Professor Shukla. Thank you for your lecture as well as setting the stage for RDS VII next month. Now I'll invite the audience to have discussion and to have Their queries cleared up with Professor Shukla. Antanu sir, yeah.
Thank you, Professor Shukla, for a fantastic talk. I'm sure there have been several queries from the audience, and it's very interesting to know that Ganga has been migrating from north to south, and now it is more or less stable, as you said. And in the meantime, Pradeep has conveyed that it is a very fantastic lecture that you have given. Congratulated you.
Your voice is very, very slow in my, I don't know, it is a fault of my laptop, your laptop.
Hello, can you hear us? Shukla?
Yeah, it's a slow, but I can listen it.
Could you hear us? I think yes, right? So there is a query from Dr. Abhinav Roy.
Yes.
There is a query from Dr. Abhinav Roy. Abhinav Roy, please go ahead with your query.
I must at the outset thanks Dr. Shukla for an excellent and informative talk.
Thank you, sir.
I'm really feeling much knowledgeable now about these Ganga incisions. I've got some silly points to discuss. That is about the faults. You have
Yeah.
raised the point that tectonics is the cause for the incision, no doubt. It's a good one. But about the kinematic or the geometry of the faults, I've got a little problem because most of the thing you have shown that is a low angle reverse fault or thrust fault, where the
Yeah.
sediments are not showing any evidence of other deformation like your ductile deformation like folding or anything. So this is just a brittle thrust like thing you are emphasizing, I feel.
No, I have shown you the anticlines and the synclines, the steep dips of the beds which are dipping away from the main channel.
No, just very close to the past you have shown. There is the beds are all straight. I found that's the thing. One interesting thing, and secondly, that about these liquefaction features you are said, and
Hmm.
so liquefaction features. Of course, the photograph I could not make out much because liquefaction features, if they develop, there must be many such things, not the simple sand dikes. There may be other liquefaction features. I think you must have encountered. If you could show or
Yeah, they are the thing is that the grain size is very finer, so they are not standing out very prominently. You have to. I think my camera had a limited capability, so it picked up only those only. But they are there. They are in the present
okay,
in the
good.
beds.
Another just point is that incision, most of the faults you have shown, they have a strike along north-northeast, isn't it? So they appear to be cross faults, not the main longitudinal faults, isn't it?
Yeah, it may because I believe that a fault along which the Ganga is draining, it is not a individual or a single fault. It must have the associated fault structures. So in this area, I think the structural work is very much needed to further elaborate the study which I have shown you. I welcome the structural geologists to Varanasi to work at the Ramnagar cliff. I can be a good guide for them, and they can do some more and better work as far as the structural
No,
thing is concerned.
that's fine. Just my point is whether these cross faults, not that these striking faults, are responsible for the incision. That's the point.
Uh, Pardon, please speak again.
Whether these cross faults, I mean, not that these striking faults, are they responsible for incision of the Ganga?
Yeah, because this fault is affecting both the package 1 and the package 2, and both the packages are showing the features of the liquefaction as well as the tectonic features like the fold and the anticlines, associated synclines. The top surface is also going up and down according to that. So it shows that it has affected both the packages tectonically.
Thank you. Thank you very much.
Yeah.
Any more queries from the audience? We are expecting more queries from young people. Hello. Yes, Jyotirmoy, please go ahead.
Hello, sir. Good afternoon. Fantastic talk. I just have one small question. You talked
Yeah.
about the anticlines and synclines, but looking at the deformation, the depth of deformation, this must be brittle deformation dominated zone. I mean, we are not talking about deformation happening at a large depth, and cataclysmic deformation mechanism must be prevalent in such cases. So how do you explain the formation of such anticlines and synclines in such shallow deformation depth?
Yeah, you are very true. You are very true that the folding must take place below. Folding must take place below, and this is this question has a wider implication. And then we have to go to the nearby area, which is just 50 kilometers away from here, the peripheral bulge, which is the which is also tectonically active, and being a response of flexural rebound of the craton due to the thrust sheet loading in the Himalaya. This part of the area which is near to the peripheral bulge is under the influence of extensional forces, not the compressional. This is the extensional regime, already also written by many people, Lucknow University, that this area they worked near Dhasan and all that. I think Pradeep was the party there. So they have shown that this area is under the extensional regime. So the presence of the folds and the faults and the folds, because here is the reverse fault, which I have shown you, and the area is of the extensional regime. So there must be many things controlling the formation of the reverse fault and the folds. But certainly, as far as the deformation of the surface alluvium is concerned, I think as compared to the rocks, because such features are not present only in Varanasi area, we have seen along Yamuna at many places that the dips are in different direction, dipping at 10 degrees, 15 degrees. So there must be some mechanism where available by which the alluvium is folded, not going much below the surface. And it is for the structural geologists to find out that how and what was the mechanism. I invite to Varanasi.
Sir, my only humble argument here is maybe such change of deeps can be explained by other mechanisms, just by the presence of faults, not necessarily we need to draw the conclusion that there were anticlines and synclines. I mean, deep can.
Okay, then I agree to you. I agree to you. Yeah.
So, thank you, sir.
Yes, Pradeep, please go ahead.
I wanted to discuss this further. Can there be this groundwater interaction with sediments play some role in providing plasticity or some ductility to the sediments? Because you see, I mean, this part is the distal end of thrust fold belt, and not much work has been done to understand the deformation at this distal end. And these kinds of work is one of the very few documented work, but we need to understand the dynamics, as Jyotirmoy also, Aaj and Abhinavada also discussed. So I believe that some ductility must be imparted by the groundwater or the pore water which is present there in these basins. So what do you think about these things, Shantanu, or Jyotirmoy, in fact?
Yeah, I think you are very much right to say this, and this is really a new, and you have added a new dimension, that how these structures can be explained. And I think I appreciate your suggestion. And one must look at the role of the pore water pressure in the deformation in the alluvium.
At such shallow depths, almost near the surface, the dominant mechanism of deformation must be granular flow rather than
Sir, please repeat it. And
the dominant mechanism of deformation must be granular flow.
yeah.
It is not like the usual brittle or ductile deformation that we expect in hard consolidated rocks. This point you should keep in mind. And
Yes, sir.
Whatever
Yes, sir.
points.
Yes, sir. Thank you, sir. Very important points.
Can anyone elaborate upon it a little bit? What Dhruva sir has mentioned. Shantanu, can you elaborate upon it?
Yes, Pradeep, what
Yes.
said that the deformation in this shallow part is mainly dominated by granular flow. It is not purely brittle deformation, not purely ductile deformation.
So what imparts this flow dynamics kind of thing? What is the force?
I think you were little bit in a line to say that maybe the pore water content. These sediments are not consolidated one. Okay, these are
Yes.
unconsolidated sediments.
Yes.
So if you think of just like a mud layer, if you push from the both ends, there will be folding if there is some viscosity contrast.
Yes.
Okay, so the unconsolidated layer may also lead to folding in some places.
Okay.
To my understanding, it goes like that.
Yeah.
Yes. Thank you.
Yeah. Thank you, Shantanu.
You're welcome. Yes, somebody is knocking.
Subhata.
Yes, please. Dr. Ghosh?
Hello, can you hear me?
Yeah.
Can you hear me?
Yes.
Okay.
Yes, I can.
I was just thinking about the possibility of some kind of influence of the ramp flat geometry of the thrust. What Professor Shukla has shown in the sections, there the thrusts are not perfectly planar and sloping. Some kind of ramping is there, some kind of flat geometry is there.
Yes.
That the anticline is above the ramp and syncline is just beside it. So whether the ramp flat geometry of the thrust has also some influence in developing such folds, I think that may be a possibility. But of course, Jyotirmoyji's question was very good, and Professor Dhruva Mukhopadhyay has nicely explained that we cannot expect brittle ductile, very traditional or conventional brittle ductile deformation in shallow depth zones, particularly with unconsolidated sedimentary materials, layered materials. Okay, that is just a little bit of input from my side. Thank you.
Thank you. I am enlightened. I am certainly enlightened, and I will.
Yes, Professor Dilip Shah, sir, please go ahead.
Can you hear me, please?
Yes.
Sir. Yes, sir.
Professor Shukla, first of all, congratulate you for giving us such a nice talk on which I was at least not very aware of. But I have some clarifications to ask you.
Yes, sir.
First of all, can you still hear me?
Yes, sir. I can. I have difficulty in listening because I think my laptop mics are not working properly, but I can listen you. Yes.
Okay.
I am closer to my ears closer to my this mic, so I can listen.
Yeah. The issue that came to my mind is, say, for example, you said that the older sediments,
Yes.
which are around, say, older than, say, 40 kilo years, they are derived from the peninsular region and they are more arcosic compared to the younger horizons. The question that comes to my mind is that has there been any detailed study on the paleocurrent pattern of the so-called peninsular derived sediments? This is something you could say elaborate on, please.
Yeah, certainly. I have seen the cliff section here at Ramnagar, and I could notice the presence of the cross bed. But I think, the limited one or two readings from here, so I generally do not show and did not publish the paleocurrent data because the data was not enough to publish. But it was showing the trend towards the north. In general, it was towards the north transport. But we have the much more data and the comprehensive paleocurrent analysis of the cliff sections exposed along Yamuna, and we published it in Triple P. And that also shows that the sediment was transported towards the north and towards the northeast, and there was a propagation of fans from the peninsular part or the peripheral bulge also, and those sediments were reaching up to very far from south to north, and maybe up to Kanpur and so. So if they can, people have also published that some Creton derived sediment from the Kanpur borehole also. So these sediments were moving towards the north. So from that part, from Yamuna sections, we have the indications that the sediment movement was towards the north. But here at Varanasi, since that lithofacies was, there was a limited scope along to stand and to take the measure, but cross-bedding was there. I measured it, and it shows that the sediment movement is from south to north.
Yeah, that's fine, but we are in a sort of large fluvial system where the dispersion of the paleocurrent would be very large. Is it not so? So if, if you have fewer measurements pointing towards north, that does not, I mean, for me, I am not a sedimentologist, but for me, I mean, the dispersion would be so large that you can get some measurements which are towards the north. But there could be other measurements also.
Yeah, it is true. Even within a single river system, there may be the geomorphic points where the paleocurrent can show the reversing pattern. Even we get herringbone-like looking cross bedding in the braid bars, because we have dissected huge braid bars of the Ganga river at Bithur, and we published it in sedimentary research, and you can see that the braided rivers, they have the more variance than the meandering rivers, which is again against the published literature or the books, where it is shown that the meandering rivers always have the larger variance than the braided river systems. But our results were altogether reverse of it. But we have seen in the pits, which were about 1 to 2 meters deep and squarish and 1 meter wide, cross bedding was even bipolar in those pits, individual pits. So you are very much true to say that the variance of the paleocurrent should be high in such type of setting. I agree with you. But as I told you that in this clip section, there was a limited scope to do it. I took 1 or 2 readings just to see from where the sediment is coming. So it is thing which should be explored further.
Yeah, thank you, sir. One other point that comes to my mind is that your faults, northeasterly trending or northeasterly trending faults, either along, say, Jamuna or near Varanasi. I mean, these are these. I'm just trying to get some information from you. These are only cutting the alluvial. I mean the quaternary and nascent sediments, or are they originating from the basement of the peninsula?
No, I can't say. But it is true that the basement structures, highs and the faults present at the basement, they had been the controlling factor of the alluvium thickness within the foreland basin setting. And since we are very near to peripheral bulge, so Creton should be at shallow depth. But we have the borehole data from the BHU campus, where the boreholes are going into alluvium up to 400 meters. So certainly the basement is below that. So, but to look the faults at the surface and to say whether they are interacting with the basement, I can't say.
Okay. Okay. Thank you, sir. Thank you. Hopefully, we will meet during the SGSTI meeting that Shayandeep is convening. So, in few weeks' time, we will be meeting, I hope.
Yeah, welcome, sir, to Varanasi. We will meet and we will talk. And if you are interested, I will take you to Ramnagar Cliff.
Okay, thank you so much for your offer.
Yeah.
Any more, please?
I have two more questions. Can I ask Shantanu?
Sure.
Okay. Sir, one regarding the fault, the regional fault that you have proposed, which is northeast southwest trending, and you said that this is the flowing of the northern flowing Ganga is opposite to the regional slope. So how about the local slope near the fault? Is it still towards southeast, or the slope actually changes near the fault?
Yeah, because here the river has taken altogether a different course. Because if you see up current from the Chunar, you will see that the river is flowing towards the southeast, and just at the Chunar it takes a U-turn and it flows then towards the northeast up to the Saidpur and beyond, and again it comes back and follows the southeastern slope. So it was one of the evidence I have taken that since for a certain distance river is changing and flowing in a opposite to the slope, so that must be a fault control. So
no, sir, that I understand. Now, if you just prepare a slope map from your satellite imageries, do you see a change in local slope near Varanasi?
No, as such, there is no slope. If you see the geomorphological setup of the Varanasi area, which has been done and it is a half left, it shows that Varanasi area is characterized by the wide low-lying and the high up domal structures all in the area. So this surface shows a differential topography. So if you see the slopes may be variable in this area. That if you are on a region of surface, it can slope in different directions. And if you are in the low-lying area, it can show a different direction. So I think that is beyond the resolution of Google, and one should have the high resolution data to find out it. And one has to make a 3D model for this to find out that whether in Varanasi area where the river is taking the opposite course, what is the regional slope?
Okay, and sir, are there any seismic sections in the area which can actually confirm the presence of the fault or the nature of the fault?
I have seen the Ramnagar cliff. I have published the Ramnagar cliff, where, like Dilip Sahaj sir was telling, there is a liquefaction which I have shown.
No. Yeah, I'm asking about like the deep seismic profile.
Okay, published seismic profile. We have a person in the geophysics department just below this department. The person came from NGI. I'm missing the name. He is working in this area particularly for this purpose, and recently he has published a paper in Quaternary International where he has discussed, I think, about the seismic sections and the seismic profiling and all that. He has attended this.
Okay.
So the data is coming up from the geophysics department. They are working.
Okay, so the last question, you said that this is a right lateral strike slip fault, if I have understood correctly.
Dextral.
Dextral strike slip fault.
Yes,
so what was the rationale behind it? How do you
shifting of the river confluences. Shifting of the river confluences.
Okay. Thank you, Shantanu. That's all. Thank you very much, sir. Thank you.
Thank you, sir.
Shukla sir, you think you were talking about Professor Umashankar?
Umashankar, yes, Umashankar. He is doing in this area. I was missing the name. Dr. Umashankar, who came from NGRI, he is working, and one PhD student is also working on seismics and all that in this particular area. So in the future, he may come with the better data.
Any more queries, please? Otherwise, we are coming to the end of this session. It was a fantastic session, basically. Before I end, Shuklaji.
Yes.
Do you think that there are different order of meandering?
Please.
Do you think that there are different order of meandering?
Shantanu, please speak loudly, please.
Do you think that there are different order of meandering?
Different order of meandering?
Yeah.
So the part that you have shown, that this is a fault, northeast southwest fault.
Yeah.
Don't you think this could be a higher order of meander?
Yeah, I was not just talking of the order of meanders, but I was talking of the deformed meanders, that they are not the smart meanders which are regular and which have generally the wavelength, similar wavelength. Here the Ganga is showing the different shapes and the different size of meanders. Means they are the distorted ones. They have been worked upon by some allogenic force, and I ascribe it to the activity of fault.
Okay. My suggestion, I was thinking whether this northeast southwest part could be a limb of one meander, basically, or one lower order meander.
No, I think it is not so, because the meandering is the autogenic phenomena of a river system, and depending upon the morphometry of the river, it forms its own meanders, which in normal conditions they are very regular, and they have a cut side and concave side and a convex side, and generally they match in dimensions.
Okay, thank you. So if we don't have any more queries, Shandip,
yes, sir.
Close this session. If you have any queries, go ahead, Shandip.
No, sir, I think there are no more queries. So thank you, Shuklaji, again.
Thank you giving me chance to interact with my friends are there, my gurus are there, and all there. I have today the more insight that how a layer can deform. So I can think furthermore to explain in the next lecture. I will incorporate all these things, so my lecture would be better.
So let us give him a big round of applause.
Yes, sir.
Thank you.
Thank you so much, Shuklaji. Meeting you soon next month. Pradeep ji, aap bhi aa jao.
Yes, sir.
I'm asking Pradeep to join SGT RDS VII.
Right, sir. Please come, sir.
I will try. Hello, Arko.
Hello, sir. आप भी आ जाइए.
Good to see you.
Thank you, sir.
Okay then. Okay, Shuklaji.
Thank you, Santanu. Thank you. Thank you. Bye-bye to everybody. Nimir Mandal, sitting there. Hi, hello, namaskar.
I greatly enjoyed your deliberations.
Yeah, I'm fine. Fine. How are you?
It's fine. It's going on.
Yeah.
Bye.
Bye. Pradeep, please.
Bye. Thank you. I'm going to leave. Thank you.